Okay. So today, like I said, we're going to look at similar triangles. Now, we've already talked about congruent and similar shapes. Can any of you remind me, what does similar mean when we're talking about shapes?
It has similar is the same exact angles.
Yes. So similar shapes have the same angles, but they can have different side lengths than the other shape. So two similar shapes can be different sizes, but they need to be the exact same shape. Okay. So here's the things that you'll want to write down. You basically just need these first two lines. For two triangles to be similar, they must have all three angles the same. So all three of their angles must measure the same thing. And then the side lengths can be different, but they will be proportional. We'll talk about what that looks like in just a little bit and how we can use that information as well. But for right now, we just need to know those two things. And also the angles can be rotated or reflected. So as you guys know, you can turn a shape or you can flip a shape over. It doesn't change what the actual shape is. So I'll give you a minute to write this down. Make sure you've got this in your notes. And then we'll start looking at a few examples. While we're at that, there's Jocelyn. Does that mean it added, Riley? Okay, cool. So those of you that just showed up, we are currently taking just a little bit of notes, and then we're going to move on to doing some example problems. So you really want to get these first two lines written down. For two triangles to be similar, they must have all three angles the same, and the side lengths can be different, but they will need to be proportional.
So, by that metric, that means that every single equilateral triangle ever is similar?
Yes. That is 100% accurate. Okay. So I'm going to move on. If you haven't gotten these down yet, I can come back to them in a little bit. But right here, we have 6 different triangles. There are 3 pairs of similar triangles. So what I want to see you guys do is identify which of these triangles are similar and which ones, or so what are the similar pairs? So for each triangle, there should be one similar triangle somewhere else. So just list your pairs together, see if you can figure out which ones they are. Give you about a minute or so to do this. Yep, that's right, Todd. Aiden, that's correct. Dane, those are all correct. Aiden, that's also correct. Good, Pamela. I think on all 3. Yeah. Good, Aiden. Good, Jocelyn. Maybe 30 more seconds. Jennifer, the first ones are right. The second set should be separated. You categorized them correctly, but okay. So as we can see, we've got 4 right triangles. So A, B, D, and E are all right triangles. C and F are isosceles acute triangles. So the first pair is C and F. That's pretty easy to figure out. They've both got 70-degree angles in one part and then a 50-degree angle, 70-degree angles, and a 50-degree angle. The right triangles are a little harder to distinguish. So let's look at A. So what we're looking for to find the pair that goes with A is we're looking for an angle with a right, or a triangle with a right angle, a 60-degree angle, and a 30-degree angle. So if we look at B, that has a right angle of 40 and a 50. D has a right angle of 60 and a 30. So A is going to be paired with D. And then E, the other right triangle, has a right of 40 and a 50, which means that that is going to be paired with B. So our pairs should look like this. Got B and E, A and D, and C and F. And we can list out the angles for each one if we want to, just if that helps you visualize it. So this one has a 90-degree, 40-degree, 50-degree, and D have a 90-degree, a 60-degree, and a 30-degree, and C and F have 70-degree, 70-degree, and 50-degree. Okay, any questions about that? Because next we're going to move on to a pop quiz. That's totally not actually a pop quiz. Okay. So what we're going to do is I'm going to use a poll to ask you whether the next, each slide you're going to see a pair of triangles, and I'm going to ask you whether it is congruent, similar, or neither. So we've talked about similar today. Similar means that it has the same angles or it's the same shape but a different size. What does congruent mean? Does anybody remember?
Exactly the same.
Yep, so it has to be the same shape and the same size for it to be congruent.
And it
Also,
can't
I got
be-
a new like movie chair and it's hard not to. Anyway, all right, so first one, are these two triangles congruent, similar, or neither? And let's see if I can, where's my poll? That's not what I wanted. Here we go. The option is for neither, Todd. So give everybody 1 minute on this. If you don't know it, please at least guess. If the poll hasn't shown up for you, then put your answer in chat, I guess. Or if you accidentally exit out of it, put your answer in chat.
Well, if you exit out of it, all you have to do is just press the zoom icon again and the polls bring up. Unless you've already.
I haven't ended it yet. So 20 seconds left. And I still have 7 people left to vote. 6 people left to vote. 5, 4, 3, 2, 1. Okay. So it looks like we're actually somewhat evenly split. So first of all, the first thing we want to check when we're looking for similar or congruent shapes is the angles, because that will tell us whether or not they're similar to begin with. So we've got a right angle and a right angle. So both of these have a right angle here and here. And then we've got one line marking one of the angles, and we have 2 lines marking the other 2 angles. In general, if you see these kinds of markings on triangles, these 1 line versus 2 lines, what that's telling you is that these angles are the same. So all the angles with just a single arc are the same, and all the angles with a double arc are the same. So this is telling us that all of the angles in both of these triangles are the same. They each have 1 right angle, 1 single arc angle, and 1 double arc angle. Then the side lengths, in this case, only matter to tell us whether or not they're similar versus congruent. We've got a 10, whatever the unit is for this one side, a side that's 20, and on the other one we have a side that's 10 and a side that's 5. So these are similar because they're different sizes, As you can see, the 5 is proportional to the 10, and the 10 is proportional to the 20. What is the factor of enlargement between these two? So how much bigger is triangle A than triangle B?
Can I just say it?
Yeah, go for it.
Somewhere between 1.99 repeated and 2.01 repeated is my guess.
It is somewhere in between those, but those aren't as close as you think they are. Yeah, so it's 2 times as big, right? We multiply the side of 10 by 2, we multiply the side of 5 by 2. So let's say, and this is not accurate, but let's say that this side length is 12. What would this side length be?
About 23.99, maybe a little better.
A little bigger? So yeah, it's going to be 24 because we just double each of the side lengths. All right, let's look at the next example. So you've got 2 new triangles. Are these similar, congruent, or neither? I actually need to move this so I can see. Got another 30 seconds left. Todd, you know what? You know what? 15 seconds. Get your votes in. 5, 4, 3, 2, 1. All right. So we didn't get very many votes that time, only 10 out of 17. But most of you got the correct answer. So these ones, we can look at the angles again. So they both have a right angle, which is a good start. But then we've got this single arced angle and a double arced angle versus 3 arcs in this one and 4 arcs in this one. This means that all of these angles are different. And since the true triangles have different angles, they are neither. Now, the other thing we can look at in this one is actually the side lengths. So these are also not proportional side lengths. We have a 5 and a 15. If we multiply 5 to get up to this 15, we'd have to multiply it by 3. 15 times 3 would not be 25. It would be 45. So we have different proportional side lengths, or the side lengths are in different proportions to each other. So that's another way that we can look at this one. So these ones are neither. All right, let's look at the next pair. We've got 2 triangles. These are not right triangles this time. Both are isosceles. Are they similar, congruent, or neither? Thirty seconds left. Still got about half of you left to vote. $15. I know there are more than 10 of you here. What's going on? If you don't know, just guess.
I duplicated myself 7 times. So there is only 10.
Okay. 5, 4, 3, 2, 1. Okay. So most of you got the right answer on this one as well. These ones, it was a little bit of a trick because I put the side lengths in different areas, but these are actually congruent. Congruent. So if we look at the angles, we've got isosceles triangles with the first, or the lone angle being a single arced angle, and then the 2 similar or congruent angles are both double arced, and that's the same case for this one. If we look at this, the bottom 15 length side is in between these two double-lengthed arcs or double-arced angles. And then if we look on this side, the side length of 15 is also the one that goes in between these two double-arced angles. So we know that this is the same exact shape. We also have the side length of 20 labeled on both of them. And since this is an isosceles triangle, we can actually fill in that this side is 20 as well. Okay. Let's move on to the next one. So are these two triangles similar, congruent, or neither? Got another 30 seconds. I need like Jeopardy music playing.
Play Final Jeopardy.
10 seconds. 5, 4, 3, 2, 1. Okay, looks like most of you got this one as well. So for this one, we didn't even get side lengths, so we have to look at the angles. We've got one angle here with a single arc. We've got one angle with a double arc and one angle with a triple arc. Here we have a triple arc, which is good. That means they have at least one angle in common. But then we've got a 4-arced angle and a 4-arced angle. So this is an isosceles triangle. This is a scalene triangle. They have different angle measures for most of their angles. They share one in common, but that doesn't really matter to us. So these ones are neither. Okay, I think we've got one more. Yep, one last one. So put the poll back up. Are these ones similar, congruent, or neither? $30 seconds. Oh boy, we're very split on this one. 15 seconds. 5, 4, 3, 2, 1. Okay. So this one we were very, very split between all three answers. Technically, 2 of them are viable here, but not really. So mathematically speaking, if we're not given side lengths, we can't say whether or not the side lengths are different. So if you had this on a test and there was no side length labeled, you wouldn't technically be allowed to say that the purple one is bigger than the green one, but we can definitely see that it is. So they're these different sizes, which rules out congruent. Then we look at the actual angles. So this one has an 80, a 45, and a 55. This one has an 80, a 55, and a 45, which means they have the same angles. So these two shapes are similar. If you said congruent, you're technically not mathematically wrong in that, like I said, I could just tell you that this is 10 and that this is also 10. I just didn't draw it to scale. But obviously we can see that these are different sizes. So realistically, we should be able to determine that these are similar. But okay, I believe that's it for our little quiz game thing. So what we're going to do now is we're going to move on to how to actually use similar triangles to make calculations and inferences about other ones. I don't think it was exactly 90 degrees clockwise, Todd, because I moved it at a weird angle. But you're correct, it was rotated and dilated. So there are 2 aspects of similar triangles that can be used to calculate missing variables. All corresponding angles in similar triangles must be the same. We already wrote this down. You didn't use the word corresponding, but hopefully we can fill that in. And whoops, all corresponding sides in similar triangles must be proportional. So I'm going to talk about what this means in just a second here. So what we're saying is that all corresponding angles must be the same. What that means is the biggest angle in a triangle, if these two triangles are similar, the biggest angles must be the same. The second biggest angles must be the same, and the smallest angles must be the same. So in this case, I have a 3. So we used congruency marks for our angles. So we have a 3-arced angle here, a 2-arced angle here, and a 1-arced angle here. And we're asked, what is x? So without me actually explaining it, can anybody tell me what x is? Todd and Pamela, that's right. Dane, that's right. Barb, that's right. Yeah, so a few of you were able to get it. So since the single arc angle is going to be congruent in both triangles, that means that this angle and this angle, the ones I've highlighted in red, are the same. So x must be 43 degrees. Here we can also fill in the other ones. So the one with 3 arcs, for instance, has to be 80 degrees. And the ones with 2 arcs has to be 57 degrees. And that's just by virtue of the angles having to be corresponding to each other. So even though this is rotated, all right, we kind of took the triangle and moved it a little bit this way, and then we made it smaller, these angles are still corresponding to each other. So they're still going in the same direction in this case, right? So like the 80, if you go this way around, you'll get to the 43 and then to the 57, same with this one. So if you start here and you go in this direction around, go from the 80 to the 43 to the 57. Okay, now I want you to try it on your own on this one. So these two triangles are similar. What is the value of x? Now this time there are no congruency marks, so you have to actually use the sides to identify which one is which. Pamela, that is correct. Todd, that is correct. Dane, you fell into my trap. I need like the Yu-Gi-Oh thing. You've activated my trap card. Jocelyn, that is correct. But Dane, that's good. I wanted somebody to do that at some point. I'll explain in a second. I know there are more than 4 of you here. What do you guys think? Let's see. I haven't heard from Aiden or Brennan or who else is here? Jennifer or Carter or Benito or Phoenix or Asa all day. Good, Aiden. Brennan, you did the same thing as Dane. So I'll explain in just a second. Asa, what do you think it is? So I see you're talking now. Yeah, what is x? Good, Jennifer. Asa, so okay. So a few of you, or a lot of you got this right, and a lot of you made the same mistake, which is actually a mistake that I wanted people to make. So if we look at these triangles, our 20 side gets reduced to 10, our 16 side gets reduced to 8, our 24 side gets reduced to 12. These have a factor of enlargement of 2. So basically this triangle is 1/2 of this triangle, right? However, the angles don't actually change based on the size. So if we halved all of the angles, right? So if we took half of 75, we'd be at 37.5. Half of 45, we'd be at 22.5. And half of 60, we'd be at 30. These angles would now only add up to 90 degrees, and that doesn't form a triangle. So the angles stay the same, even though the side lengths got half as big. So this one is still going to be 60 degrees. This one's still going to be 75, and this one is still going to be 45. Right? Any questions about that? Okay. Let's move on. We're going to make things just a little bit trickier. We've only got 2 more slides, and then I'm going to let you guys get out of here and get started on your homework. So this time, we want to actually find our side length. So we want to find x in this case. Now, in order to do this, things get a little bit trickier. First, we have to identify which side is corresponding to which side. So we've got this side of length of 20 that's in between the 50-degree angle and the 60-degree angle. So if we look here, we have a 50-degree angle, a 60-degree angle, and now it's equal to 5. So we know that this side that I'm circling corresponds to this side over here. If we look at x, which I'll underline, that's in between the 60-degree angle and the 70-degree angle. And luckily, we were given the side over here that corresponds, which is 16. So these two sides are corresponding. So what we need to do, since we know that similar side lengths in triangles are proportional, we need to figure out what the factor of enlargement is here. So how did we get from 5 to 20? What do we have to multiply by?
At least 3.99 repeated.
That's very true, but it's not 15 or 20. So you want to narrow it down a little further?
Lower than 4.01?
Okay, so it is 4 times as big, right? We multiply 5 times 4 in order to get to 20. That means to go backwards, we divide by 4. So from 16 to x, we need to divide by 4. So we should get x equals 4. That'll keep these in proportion. Now, quick question. This is a little bit advanced and extra. You don't need to know this, but I want to see if anybody does. Is this side going to be the biggest side, the smallest side, or the middle side in terms of length? Anybody?
What I'm thinking. I'm using some logical expertise.
Sounds good. I'll give you a minute. Not quite, Asa. There you go, Asa. Now you got it. Yeah, Jocelyn, good. Okay. Looks like some people are getting it. So this side length is actually going to be the middle side length. And the reason is it is opposite the middle angle. So you'll notice that the smallest side on this one is opposite the smallest angle. So our 50-degree angle gives us our side length of 16. Our 70-degree angle gives us our side length of 20. Our 60-degree angle would have to be somewhere in between those two. So possibly somewhere in the 18 range. I don't think it's quite that, because that's not, angles aren't quite that nice. That would be convenient though. But yeah, like that is very true, Todd. So as the angle gets bigger, the side length is also going to get bigger. Oh, might have said the opposite. Okay. So last thing that I want you guys to do is see if you can solve for x and y in this triangle. So we've got 2 similar triangles. This time, instead of giving you angle measures, I gave you congruency marks. So you're going to have to identify which side corresponds to which side, but it's kind of easier on this one because it's a right triangle. So if you can tell me what x and y are, then you'll be good to go. Your homework for today is, let me double check and make sure I have the right one. Where is it? It's either similarity in triangles or IXL's Q5 and Q6. The math-based task for this one, it is in the triangles unit. And unfortunately in math space, they do proofs during that unit. So you have to go and find a reason for every answer. So I think that the IXLs are a little bit easier, but it is still up to you. You can do whichever one you want. Those of you that have answered so far, as far as I can tell, everybody is right. Can all of you tell me which angle is smaller, the single one or the double one? I'm adding something extra to make you work a little harder. Correct, Aiden. Not quite, Todd. Correct, Pamela. Well, yeah, that's the only other option. Okay, so if you got that done, you're welcome to take off if you feel like you've got a good handle on this. Otherwise, feel free to stick around and get some extra help. Those of you who haven't gotten it yet, I'll explain in about maybe 30 more seconds, but I want to give you a chance to try it on your own. Good, Brennan. That's the right side, Jocelyn, but not the right length. Barb, that's correct. Asa, that's correct. Okay, so those of you that are left, we know that the side 4 here that I'm going to circle corresponds to the side 12. The side 9 corresponds to the side X, and the side 15 corresponds to the side Y. So we know that those are the same ones. Yeah, Asa, you can take off. So what we need to do is figure out how we get from 4 to 12, or 12 to 4. So how do we get from 12 to 4? What do we have to divide by? Yeah, exactly. So we have to divide by 3 in order to get from 12 to 4. So that means in order to get from 15 to Y, we have to divide by 3. And in order to get from 9 to X, we have to divide by 3. So that's going to give us X equals 3 and Y equals 5. And then that last part I was asking was just about which angle is going to be bigger or smaller. Like I said, the bigger the side opposite an angle, the bigger the angle compared to the other ones. So in this case, since our smallest side is over here, it's opposite this angle, which must be the smallest angle. So this would be small angle, this would be medium, and then this would be the big one. All right, so you guys are good to go. If you need help or if you want some extra practice, please stick around. And then obviously there was one of you that I talked to already.